Hello to everyone. My name is Aleksei Khromenkov. I am a Golang developer in Traffic Stars company. Previous speakers told you enough about streaming processing, but I would like to tell you in a different view. And the main theme of this presentation is Kafka stream processing in Go, or how to process Protobuf data in Kafka. I hope you are all familiar with these concepts. Okay, about the company and me, we are the advertisement network, and our primary mission is to deliver the best offers to our clients. Our platform has direct traffic and RTB, real-time bidding integrations with other partners. For this moment, we have over 5 billion daily ad impressions. It's about 800,000 events per second in the peak. And also we have 25 billion auctions per second. So the problem, because of companies' growth, sooner or later, any system can begin to degrade over the time. In our situation, we have faced this, that it's becoming more and more difficult to support business needs. Traffic is growing, infrastructure is at its limits, and scaling both horizontal or vertical doesn't help anymore. And it costs too much as well. So the current system is more than 5 years old, and used patterns are obsolete. Thus, any small fix may require more time, not for only development, but for debugging and testing. And what to do with this? It has to rewrite the system step by step with a thorough analysis of bottlenecks and as carefully as possible. And parallel in the current system. I'm talking about seamless migration, but this process needs separate talk. But now I would like to talk you about one step of our migration process. How it was before. Here you can see that all traffic, all incoming traffic from final data centers flows to the central Kafka in the central data center. But this is raw data, and we need to process it. For this, we have several services, both of our self-written and open source. Also, we have a special service for post-processing data and writing it to the ClickHouse. And then data in ClickHouse had been aggregated by the special service. Here, I need to explain you why we need this service, because ClickHouse has all engines. To be honest, we were the first who started to use ClickHouse in the production environment, and for that time, there didn't have features that we need. So we had to write our own service. Okay, and one of the part of this job was done by ksqlDB, and you know what is it. Okay, but I would like to explain a little bit more about ksqlDB. It can read that data from the Kafka and aggregate with the SQL queries. I mean, process with methods described by these queries. After that, it can write back the data to the Kafka with two different ways. First one, it's a stream. It's this data writes as is without any changes, and the table where values always store with the last one by the key. Beyond the simple data processing, summing and counting, etc., it is also possible to use window aggregation. Window aggregation can be hopping and tumbling. Hopping window based on time intervals, and you can process data with small steps using the processed data from the previous window. And tumbling window, it's fixed, non-overlapping windows where data processed step by step without overlapping, as I said before. The generally Kafka streams came to us from Java, as you know. The quote from the Apache's website that Kafka Streams is a client library for building applications and microservices where the input and output data are stored in the Kafka clusters and so on. Here you can see the example. It's a simple scaled stateless service and application uses Kafka Streams, serving as a producer and a consumer at the same time. Each topic in the Kafka is divided by the several parts, and these parts are balanced by case in the message for the messages in the topic. Accordingly, the messages with 1K always will be on the same part. Such partition provides elasticity, scalability, high performance, and fault tolerance. And as I said before, ksqlDB implements all the opportunities on the Kafka streams, making work easy by describing workflow with SQL. But what's wrong for us in this scheme? You know that JSON processing is a long process, and messages takes up a lot of space and poorly compressed, clogging up network channels. And the aggregation in the ClickHouse with different service, I mean with service that stays a part of the ClickHouse. It's a long process too, and there is no way to intervene the processing aggregation process without interrupting it. What's the alternative? To reduce the load on network between data centers and increase the speed of serializing data, we decided to switch from the JSON to Protobuf. Of course, we use the libraries like EasyJSON, but Protobuf is not much anyway. Moreover, the events in Protobuf format are also perfectly compressed. If you need, you can compress, so you can don't do this if you want. Okay, and here instead of running long SQL queries, we can switch to real-time data processing. But how to process the data in a new Protobuf format? If about our self-services, it's quite clear, but can ksqlDB process Protobuf data? The answer is yes, it can. But there is one problem. ksqlDB needs a special schema registry where it stores all versions of Protobuf files. Additionally, the Protobuf format have special bytes in this format. The 0 byte is serialization format version number. From first to fourth, it's schema ID, and from fifth, it's main payload Protobuf data. It's a special format for ksqlDB. What about Protobuf in ClickHouse? Okay, ClickHouse has a Kafka engine. It can read from the Kafka, and also perfect work with the Protobuf. But Protobuf needs a length-delimited Protobuf format, where the first part of the Protobuf message it's a variable variant which stores the length of the payload, of main payload of the message. So here we can see that ksqlDB needs its own format Protobuf, and ClickHouse needs length delimited, and they can work together easily. What if give up using ksqlDB and start using libraries from Go, because we write services in Go? Take a look at some of them. The first, it's a Confluent Kafka Go. It's a Confluent library for Confluent platform. It's developers of the ksqlDB. Then Serama, it's the most popular and powerful client, but needs some boilerplate. Kafka Go, it's the easiest client for just writing and reading from Kafka. And the last one, Goka. Goka under the hood is the same Sarama, but it provides the Kafka stream processing. So do we really need ksqlDB? After trying different variants, we consider that we can abandon ksqlDB. And instead of it, it's possible to implement several services that can handle messages in real time in Go. And we start to use Goka as well. And of course, we can use Protobuf format that ClickHouse understands in all services. 2 words about Protobuf. You know that I need to generate code from Protobuf to code. Has always been a little bit inconvenient. But the service buff build is solving this problem. Here you just need just download the tools, upload your Protobuf file to the repository, then just make go get, and you will get all generated code directly. Okay. Here you can see how to work with Goka. It's a simple application. To start in it, you should describe all input state. It's an input topic from where you want to read messages. Codec. It's like a serialization algorithm. For example, for us, it's a Protobuf serialization. And the callback. It's a main method where you can process the old data. And of course, write back to the storage or to the output streams or any way you want. Also, you should describe output table. Output table, it's a main state of the application, and when application restarts, it reread its state from this table or from this topic. Okay. There is an example. You can see that it's very simple. Here you can describe a callback when we would like to process data. For example, it's simple counter. Then you should describe a group. It's a processing group where you can describe group name. It's main of the storage. It's the name of the table where you store all state of the application. Input information, it's a topic input. Codec, as I said, it's a serialization algorithm. And callback. And here the codec in which format you store the data. For example, it's counter int 64. And then just run this process. Okay, is it enough to use this library? Not completely. Unfortunately, they have enough open issues. They can't pause and resume consumer, but they have pull requests for it. And they have no window aggregation. But they have open tissue, and what we can do if we need this window aggregation? We can wait while they solve this problem. We can create our own implementation of window aggregation, or we can use another service, for example, ClickHouse. And I'm talking not about production cluster ClickHouse. I am talking about standalone service. Not a long time ago, experimental window view was added to the ClickHouse. In basic terms, it's a typical ClickHouse view, but with supporting for tumbling and hopping window semantic, like ksqlDB. And here you can see that we can process data from the Kafka with the Kafka engine, aggregate with the window view, and store back this aggregated data. But you know, this solution scales badly because ClickHouse needs a consumer group for reading data from Kafka. And it means that we can't read the data from the Kafka when we restart this service. And one of the solution it's store ClickHouse in the Docker container, for example, and drop the consumer group after restarting. But for simple tasks without scaling, it will work fine. And what now? You can see from the diagram what we went up with. No unnecessary services and maximal usage of native tools that we already have. But how to test this? For after test, there is no difference, JSON or Protobuf. But for manual testing, it's inconvenient opposite to JSON. And there are no freely available tools for debugging Protobuf. So we finalized a number of our internal services. It's special tools which we used for looking to the storages of any our service. We can look at the Kafka as well and read the Protobuf data with a human-readable format. Okay, in summary, we have gotten rid of legacy. We have used native and proven tools as much as possible. We have gotten less dependency on third-party applications, gotten a simplification on changing and debugging services, optimizing and scaling them. But we had to convince the business that refactoring is necessary and get the time to do it. We had to reconfigure analytical tools like Grafana and Metabase and pay additional cost during migration and support parallel computing. In total, with the same resources, we get more processing power. We are growing steadily and we be able to reuse an existing hardware. All new services are written with a clean architecture pattern, so it will be easy to understand the code and implement new features. And basically, the whole architecture was rebuilt with Solid in mind. Each component serves only a specific function. There is some links, and I told you about our experience and our research. Maybe you have a different opinion, or maybe something will be useful for you. But anyway, thank you for the attention. And if you have any questions, please, I will try to answer it. Thank you.
Did you do any research before deciding to re-implementing this on your own? Like, why wouldn't you go with some tool like Flink or Spark Streaming?
Yes, we have some research, but it's not so easy just switch from one system to another because our system is working now, and it's like to change the wheels on the running train. So we had to just rewrite the system really step by step, simply implementing one application by the one. And we haven't enough time, maybe two, so it's what we done.
Okay, thanks. And the second question is, what happens if you need a different kind of aggregation that ClickHouse doesn't support?
It's an interesting question, thank you. But I think for now we haven't this case because all that ClickHouse provides, it's enough for us.
Okay, thank you.
If you'll be, we will try something else.
Thank you for your presentation. Could you please describe what kind of scaling problems you faced with this stateless ClickHouse? Because it seemed like you could just set up 2 or 3 instances listening on the single consumer group.
The first one that for aggregation data, also after restarting, you should read all historical data because you may have this data in Kafka. But ClickHouse cannot reread this data because it needs a consumer group, and as you know, consumer group has a special offset. That means where you stopped reading.
So these ClickHouses are not stateless, they have...
Yes, that's not stateless for
got it.
this case.
Thank you.
What library in Go language do you use for ClickHouse? Is it official or not?
We use both libraries, and the first library, it's our implementation. Is I remember I said before that we are the first, one of the first who started using ClickHouse, and we had to write our own library. But yes, the second library, as I remember, it's from Mail.ru. It's support binary format. But yes, so the first library is our own, and the second from Mail.ru.
Thank you. And second question is, what total size of data in ClickHouse do you have?
Oh, good question. As I remember, it's about petabytes, maybe, yeah? It's more than several petabytes.
Since ClickHouse is not transactional, you can get duplicates in your ClickHouse. Right?
Yes, we can get duplicates, but it's interesting that ClickHouse developers recently introduced new ClickHouse or new Kafka connector, and they promised us that we'll have at least, well, not at least, exactly one method to read from Kafka. So maybe in future we can switch to this connector.
Did you try to upgrade all instances ClickHouse in the same time?
Yes, sure. It's our pain.
Is it big pain, yes?
Yes, yes. Yes, it's our pain, but it's interesting because we bought a new cluster and we start using this new cluster with a new version of ClickHouse, and the previous version of ClickHouse in the same time on our old cluster. And in the seamless migration process, we is switching from one to another cluster to the last version.
And now we have?
And now we have last version.
Usually when you use streaming aggregation, you need the final data as soon as possible. What are the latency between the very first appearing the event in your Kafka or in your system and the final aggregation that you use in your other systems?
You need it needs about seconds. If we are talking about flowing data from final data centers to central, at the peaks it may be some Kafka lag, to be honest. But in normal case, it's about just seconds, 1-2 seconds.
How much events per second you have in one topic?
Yes, not one topic. We have different topics, but yes, in one cluster of Kafka, we have a big cluster.
Yeah, so a lot of messages per second, yes?
Yes, yes.
And say if you experience some problems between data centers, what you do in this case?
About monitoring tools, we just read Kafka's metrics, and if we have some problems, you know, it's some kind of DevOps problem, not developers. But to be honest, if we have some luck, we just wait for resolving, and it's you know that this luck can reflect just for statistics, not for user experience. I mean that users doesn't feel.
But do you use this data for optimization? I mean optimization of ads. You're showing ads, right? You do the real-time optimization of ads using auction RTB.
Yeah.
Yeah, and so does it affect this kind of performance? Like if you have some lag of Kafka, say, on 20 minutes, it will affect money, right? In some sense.
It may affect money, yes. And if we have a big lag, we always investigate this situation. But usually, as I said, our old system was a little bit obsolete, and we can't easily do something on the way.
What do you monitor other than legs? Some other metrics, maybe it's useful metrics to look at the health of Kafka. What you recommend?
Just Kafka metrics with Prometheus.
But there are hundreds of them. What you look at this? It's like some important metrics that you can mention. That
The main metric is real. It's a Kafka lag from topics.
Okay, the leg is number one. Yes.
Yes.
Okay.
Number one.
Thank you.